going to grab one more link. Oops. Here, we'll cancel that for now. Hang on. Okay, so and hello and welcome to everyone to tonight's presentation of OTF Connects, Introducing Proportional Reasoning and Extensions with the 4-Part Math Lesson Framework with Kyle Pierce. And Kyle, you did win the prize for the longest title for an OTF Connects session. And very specific, and I assume that by the people that signed up that this was just what you were looking for. We're really thrilled that everyone is here tonight, and on behalf of Sirius Gurhan, who's the administrator and facilitator of the OTF Connects program, she and everyone at OTF certainly extends their gratitude for your participation and continued support for the PD programs that OTF is able to make available to its members. And we know this is your very own time, and you've certainly got lucky students to have teachers who are willing to do some extra learning on your own time and in the evening. And we're thrilled to have Kyle here. And I just want to remind everyone that if you do have any technical problems, just let us know in the chat. We'll follow up as quickly as we're able to. But right now it is time for us to go ahead and get started. So I'm going to hand things over to Kyle, who's going to introduce himself a little bit and then get us going.
Perfect. Thanks so much, Louise. I really appreciate you having me this evening through OTF Connect. This will be my first OTF Connect session. It's great to see everyone from all over Ontario, even some of us from way up north. We feel like we're way up north here down in Windsor where I am. We had all our schools were closed. The board office was closed, so not much going on today. So I was doing a little bit of daddy daycare on our end. I have a daughter who's turning 3 later this year, and my son is 10 months old. So had a little bit of fun in the snow, and I'm really excited to do some learning with you this evening. So the title is long, Exploring Proportional Reasoning Through the 4-Part Math Lesson. I wanted to be very specific. This is a 3-part series, so I will be exploring some other strands as well. But if you are aware, in Ontario, we have some issues with proportional reasoning. It seems to be one of the areas that many of our students struggle with. So that's what we'll be looking at today. But we'll also be looking at what I call a 4-part math lesson, so an extension on the 3-part math lesson, I guess digging in a little deeper, going a little more specific. So let's get started here. So I do want to give you a little bit of background about myself. I am a math teacher. I currently am teaching grade 9 applied math here in southwestern Ontario. I'm at a school called Tecumseh Vista Academy. We're a K-12 school. We are in our 4th year, so we're going to have our first graduating class. We started K-9, and I was the only math teacher in the building at the time. And now we are all the way from K all the way to 12. So it's an exciting time for us. In the afternoon, I split my schedule, and I work with 29 other schools across the district through the Middle Years Collaborative Inquiry Project. So I get to still be in the classroom, practice what I preach, try some of these things and allow some of them to fail. Many fail, and then we do some learning. We go back to the drawing board and we try it again. So let's get started with, first of all, we're going to be looking at math, but in particular, I want you to think about math class as you may remember it, and as many of us may still teach it along these lines. For myself, I'm in my 9th year of teaching, and for probably the first 8, I taught it following a very similar approach. So first off, students would come to class and we would go through the homework, ultimately taking up any problems that students had. Routinely we would have some of the struggling students weren't doing their homework, so you were scratching your head wondering, are they struggling because they're not doing homework, or have they given up on the homework because they're struggling? And ultimately, even the level 3 and 4 students in my classes would usually skip some of the questions later on, which were more or less the problem-solving problems. So that was concerning to me. But then I would provide them with definitions, formulas, procedures, algorithms, pretty much anything we're going to need for that particular class. So we're essentially starting the lesson. We get ourselves started, and I give them all of the magic that they need to make the math, make the math class work. And from there, I then provide them with a ton of examples, making sure that I'm addressing essentially every possibility that they could see in the homework so that there were no excuses. And then I would assign them a big long list of problems, whether it's 1 to 12, A, C, E, or whatever it might be. But that's how I remember math class, and I'm sure many of you remember it that way as well. So trying to break free from this approach can be very difficult because that's how we traditionally learned math. As I was preparing for this session, I came across my old finite math textbook back when I was in OAC, and I flipped around in this textbook, and you can see here that the textbook actually follows a very similar format. They give a little bit of an introduction, but then essentially they give you everything you need, and then they get into a bunch of examples. But the problem that we haven't really addressed yet is the types of examples that they give us. So if you take a look at this one, for example, list all the combinations of 3 out of 4 colors, red, blue, white, and green. Seems like a very simple question, but it's actually very abstract at the same time. So while we're only dealing with 4 different colors, we're not really dealing with something that's actually contextual or visual, and that's an issue. And as we go on and we look at part B, we're essentially looking at taking that simple or supposedly simple problem that was still abstract and kind of hard to wrap your head around, and then we extend it even further. So many of the examples look like this. They're not very visual and they're not contextual. So that, to me, is a major concern of mine. So what we get when we teach students this way is we end up with these 2 groups, and I'm sure you'll recognize the 2 groups of students I'm talking about. We end up with students who either are good at math or students who are not good at math. Now, you'll notice that it doesn't appear that there's any overlap here. You essentially, know your stuff or you don't. And that's typically the way we perceive mathematics, and that's the way a lot of people perceive mathematics, that they either were good at math or they either were not good at math. Many people think it's natural, but we'll dig into this a little bit later in the session. So just a couple things that come to my attention. When I think about students that are good at math, I typically think that they know their terminology or they understand the different math definitions and new concepts along the way, and they also know the procedures that are required in order to actually do the math. And the problem is that the not good at math group usually don't know either. So that's a huge issue. But something that is common between these 2 groups that we really miss a lot of the time is the fact that both of these groups struggle with any unfamiliar problems. And I always found this, like I had mentioned at the beginning, my level 3 and 4 students would come to school and those last few questions in the homework, they could not do them because I didn't want to essentially give them the example that covered the same exact concept, or I guess the same exact approach to the problem, and they ultimately would stumble. And that really has me thinking about how we teach and what we can do to try to address this. So rather than calling these 2 groups good at math and not good at math, what I'm starting to realize is that I think we could also rename these 2 groups those who can memorize and those who cannot. And ultimately, when we think way back to even primary grades, a lot of what we test students on is based on whether they can memorize. Do they know their times tables is the number one that you hear in the media, whether that's will make or break a math student. But ultimately, those who are successful typically can memorize the steps, the procedures, and the algorithms. So that's an issue, and I think that we can move away from this approach if we're very strategic about it. So I want to share with you a vision I have for math education, and it looks a little bit like this. First, what I think we can do is I think we can make our math tasks, whether it's examples, whether it's the questions we do in class, the types of tasks we do in class, we need to make them contextual. So if we go back to that textbook example was not contextual. Although it talks about colors, it really doesn't give you an idea. It doesn't really paint you a clear picture in your head as to what it is you're doing or why you're doing it in the first place. So making them contextual is really big. Second, I think we really need to make these concepts visual and concrete whenever we possibly can. And that may be a struggle with some concepts, but I truly believe that there is always a way to do it. We just need to find out what that looks like, what that method looks like. And then finally, the third thing is looking at math and really exploring how interconnected it is. If we go back to our textbook lessons and the way we learned and the way I taught for 8 years, essentially I was teaching concepts in silos. So today we were talking about a concept, tomorrow we talk about a new concept, but very rarely did they actually flow from one lesson to the other. And almost always, once we were done a unit, we were done that topic until maybe review time for the exam. So that's a really big missed opportunity, I believe. So I think if we can do these three things, I think what we're going to find is that students are going to have an increased level of confidence. Their perception of math is going to improve, and I believe they're also going to have an overall improvement in student success. So that's my math vision, and I'm going to share a few different ways today relative to proportional reasoning and how we can actually put this into play or into action, I should say. So to get started, I do want to quickly review the 4-part math lesson. Now, I'm going to encourage you at this point, if you want to use your text tool to the side, as we did at the start, to share what do you know about a 3-part math lesson. So what are some of the things you know, whether it be the specific parts, the 3 different parts, maybe describing one of the parts, what does that part mean to you? So go ahead and take a second and grab that text tool and share a little bit of information about what you know about the 3-part math lesson. It's completely anonymous, so if you're not really sure what a 3-part math lesson is, you can also state that as well. And just a heads up as well, right under the text box, you can change the color of your text box as well if you want to try to make it a little bit brighter. I think we can all read anyway, but just in case. Awesome. Lots of people out there with the minds on action, consolidation. I like the idea of collaboration as well. Awesome. So ministry guides, which have ready-made lessons. If you're a grade 7 to 10 teacher, you may be familiar with the Tips for RN program. Nice, some different takes on the minds on and action and consolidation. Very cool. All right, lots of great ideas. And while I know that Marianne Small is an advocate of the 3-part, and I know that she's helped develop Ontario's take on the 3-part, I believe John Van de Waal was the originator of the idea. But again, lots of different takes on it as well. Excellent. Well, I'm apologize if I'm going to be cutting off anyone mid paragraph or mid sentence here. But thank you so much for sharing your knowledge of each. I think it's great. I like the idea. I see some hands-on in there. We see some sharing, so students sharing their knowledge and understanding. Purposeful talk, excellent. Some great strategies incorporated here as well. Okay, so I'm going to move forward to the next, and just like the three-part lesson, we actually are going to maintain that idea of the minds-on, but I want to get a little bit more particular, especially when we have an opportunity. What I like to do with the minds-on, and actually it looks like Hema may have a question for us, so go ahead there, Hema. If you have a question, if you want to use your microphone or the chat box, feel free. Okay, I'm not sure. Okay, maybe Hema had hit that button by accident, so I apologize. But yes, with the minds-on, ultimately, what I'm thinking, while we are trying to activate and get students ready for that day's lesson, ultimately activating prior knowledge is crucial as well. So if we ever have an opportunity to take the previous day's lesson or previous few days' lessons and involve them in the minds-on in order to help set the stage for the new concept, I always encourage that you do so. So we'll look at an example of that today. So that minds-on, ultimately, it can be short, but it can also stretch much longer than some believe. Many think it should only be 5 to 10 minutes, but I've seen much larger. But then again, sometimes you might be arguing whether you're actually in a minds-on or whether you're into the action. So ultimately, we're keeping it fairly similar to the original three-part to start. But what I do in the middle is I try to break down the action into very specific parts, and this part is what I believe to be the most important in the four-part math lesson, and that's the inquiry piece. I know that discovery and inquiry learning often, often is bashed in the media, but ultimately I think that we are still learning as teachers. We're still learning how to effectively implement an effective inquiry lesson. So we're going to do that today. So I think it's really important that students, when we're introducing a new concept, we really try to set them up in a particular situation where we're giving them some context, we're giving them something visual, and we're allowing them to essentially find their own way to the solution, so prove to themselves that they can find the answer to the problem. And then what we'll do is we'll make a connection to where that will be leading us to in the new topic or the new concept. So ultimately that third part is part of the action. So the inquiry is going to lead us to some solution and ultimately have students, what I like to consider, bumping into a learning goal. So we have a very specific learning goal in mind, and we want them to almost accidentally, or they want to believe that it's accidental, that they bumped into this learning goal so that the connections can be made quite easily. And we try to teach them some of the effective or most efficient strategies. And then finally, we'll wrap up with some consolidation, ultimately taking that more efficient method, that more algebraic or abstract method, and applying it to similar situations that we saw in the inquiry phase. So the inquiry phase, ultimately you're getting students to believe that they can solve the problem even without me teaching them anything, and then we try to show them a more efficient method so that they want to use that math, rather than me just teaching them a bunch of examples on how to do that. So we'll take a look at that now. So what I'd like to do is I'd like to bring you over to a browser here, and I'd like to show you a short little clip, and then we're going to have some quick discussion after you see the clip. So this is about a 20-second clip, and I'm just going to do a web tour. So let's see if this actually works. So I'm going to let this clip play, and I'd like you to think as you're watching the clip, what are some possible questions that you could ask here? Some may be more obvious than others. There is no right or wrong answer. But after you take a look at this clip, take a few minutes, grab the text tool, and start bringing up some questions that come to mind. So I'll come back to the whiteboard here. You can go right on this 4-part math lesson slide. What are some questions? And you can have an unlimited number. There is no limit on how many you can offer us here. Okay, some great questions coming along here. I may have accidentally advanced this slide before I showed the video, so I may have given away one of the questions that we'll be looking at tonight, but I think you can see where we were going with that video. And if you're unfamiliar, this approach we're going to be using within the 4-part math lesson is the idea of a 3-act math task. So I'm just going to type that into the chat box. And I've given you a link there as well to a directory. Dan Meyer is one of the many math teachers doing 3-act math tasks. He is, I guess, the creator of the concept of trying to pull your students in. So ultimately what we've done is we've given students a little bit a look at this interesting question, or I guess this interesting scenario that doesn't even have a question yet, and it allows them to create the question. So I can see tons of great questions up here. Would the paper stack make a good footstool for the chair? Nice question. Can we use the paper stack as a step stool? Nice. How many stacks will it take to reach the ceiling? Nicely done. How many to the doorway? How many to fill the doorway? How many pieces of paper? So rather than stacks, how many pieces of paper? How much would it cost to fill the whole room? So we have got lots and lots of questions here. And ultimately, what I would suggest you do with this approach is taking these concepts or these questions and really trying to jot them down somewhere. If you're in a digital classroom using something like a Google Docs, or if it's Evernote or something that you can use that students can collaborate in order to record some of these questions that they have, and then also tag some names along with it, because when we look at those two groups, the students that are good at math and the students who aren't, Dan Meyer calls it, the Math Country Club. So usually it's the kids in the Math Country Club who get to raise their hand and come up with the good questions and feel good about themselves in math class. But doing something like this would allow anyone at any level in math class to put forward some questions and ultimately have a chance to maybe narrow down on the question that we are actually going to look at. that particular day. So some great sharing going on there. Thanks so much for all of your input on that. And as I mentioned, if you did see the slide advance by accident, I apologize for that. But if you saw the slide advance, you'll know the question we're going to look at today is how many reams of paper or how many stacks of paper will it take to get to the ceiling. So what I'm going to do is now share some of the information involved in this problem and ultimately let you guys take some time to actually do a little bit of the work. Now, thinking back, I wish I had inserted a few extra slides, but what I can actually do is maybe toss in a brand new page. So I'm going to release a little bit of information for you, and then we're going to have you guys solve the problem. So here are some details. Now, typically I would have my students ask me for this information, but today, just due to time and the fact that we aren't in the same room, I'm going to give this information to you. So I've got two pieces of information to give you, and we're going to come back to answer that problem, which is how many packs of paper would it take to reach the ceiling? We're going to have you guys do that is a 273 centimeters. I think we had a little bit of a formatting issue there, so I apologize on that slide. So the room height is 273 centimeters. And I'm going to have you guys, you might want to do it on a scrap piece of paper at your house or however you choose, but when you're done, we'll have you guys share out some of your information. So as you do some of this work, when you do share out your information on the screen, you can use the text tool again. I'm also going to have you try to, in words, try to explain what it was that you did to find the solution. So we'll have a quick little chat. In my classroom, I'm using iPads, so my students would use Apple TV and AirPlay in order to mirror their iPad screen. So we could also ultimately have students share their work really fast and then also have more time to actually explain what they did. So rather than having us, students sit and watch while that student rewrites their work on the board, we can actually look at their work and that student can essentially summarize it and more or less justify and try to convince the students in the class that what they're doing makes sense. So take a couple moments there, explain what it was that you did and ultimately what your final answer was, and then we'll take a little bit of time to deconstruct this problem.
Janice, I saw your hand go up there. Did you have a question? Do you want to jump on your mic?
Thanks so much, Janice, for the question. I definitely missed that. I appreciate you bringing our attention to it. Janice is asking, do you always focus on one question, or can a group explore their creative question? And I would say for me personally, typically I stick to a particular question, and the reason why I think my best explanation would be because I'm trying to select a particular question to address a very specific learning goal. So while it's not necessarily apparent to you yet what that learning goal is, obviously today we're talking about proportional reasoning, so you're definitely going to pick up on some of that very quickly. But you'll see as we do some more of this task and what we'll extend into, we'll start to talk about what the learning goal actually is that we're looking to do here. I typically don't share the learning goal with the students before the lesson or before the task, because I really don't want that to influence their question. If I say I'm, let's say doing something related to patterning, I don't want them to now not necessarily give a question that might be related to area or volume or something else. So while there are some great questions coming out, what I've tried to do is take a page out of Dan Meyer's book, and once we're done solving the question that's going to address the learning goal, that specific learning goal I'm after, we try to look back to the questions and see, okay, now that we have this information, now that I've given you the height of 5 reams of paper and the height of the room, and now that you've calculated that it will take just over 55 reams to reach the ceiling, could we go back and answer some of the other questions? So encouraging your students to try and answer some of those other questions would be great. So for example, how much would it cost to reach the ceiling might be a question that students have. So while they're working, you could have one student go and try to find the average cost for a ream of paper, or maybe go to the Staples website and ultimately answer that question. So that's directly out of, again, Dan Meyer's book, his playbook, so to speak. But I typically don't let them just go in any random direction to solve any problem. While I think it would be, probably valuable, and they would probably be more apt to put their 100% into doing something that they feel is authentic. My only concern would be, when will we know if the student is going to learn the learning goal or the intended learning goal for that day? So that could just be this, some uncomfortable, maybe it's just putting myself in an uncomfortable place, and maybe I'm just not there yet. But that, I guess, would be my best answer for you currently anyway. And then we also have Paul asking, what about some practical questions like how will we safely reach the ceiling? So definitely those are questions that will come out. And I really encourage, and I usually mention this, and I definitely forgot to mention it tonight, but when students come up with maybe more sarcastic, or maybe not sarcastic, but more or less kind of funny questions. We saw one on the previous screen. I'm trying to remember what it was. Would it work for the 5 stacks? Would it work as a footstool, for example? Really try to get students to engage in the problem, so I don't try to discourage students from having a good time and coming up and using their sense of humor. So it's a way to get everyone talking and get everyone invested in the problem. The Dan Meyer I don't believe has a book, but his blog is blog.mrmeyer.com, and his post, if you Google it, I'll try to grab that link in a second, but it's called The 3 Acts of a Mathematical Story. And he is a phenomenal speaker and has inspired me to do everything I do in terms of bringing context. I definitely, have a different approach to how I share that, but the idea of these 3-act math tasks is something that has really changed the way I do things and the way I think about math. I really try to come into my classroom, and when I have a topic, if I'm not sure how to make it contextual, then I know there's a problem. because it's ultimately the way that I learned it, and if I don't know how to make it contextual, then I know it's going to be difficult for a lot of students. As you get into older grades, obviously it becomes more difficult because the math gets more abstract, but I think whenever there's an opportunity to make it visual, we definitely have to take advantage of it in order to, ultimately hook students in, and then also give them something to latch onto. So lots of great work here. I see lots of people are using division, so taking your height of the 5 stacks and dividing by 5. Some people took the height of the room divided by the height of the 5 stacks and used that multiple. So variations, but very similar in how we all approached it. Most of us used some sort of combination of division and possibly multiplication. So awesome stuff. Thank you so much for sharing your thinking here. So much share. Yeah, next time we'll create a new slide. Yeah, definitely a great idea there, Louise. I appreciate the suggestion. This is my first time in Blackboard Collaborate, so I definitely feel free if you want to make that suggestion earlier if I forget again there, Louise, because we'll be doing some more sharing out as well. So awesome stuff. Awesome to see everyone really engaging in the lesson. So what I'd like to do right now is take a moment to actually allow you to see the solution. So that's another advantage of using a 3-act math task like a Dan Meyer style problem. This task I created. This is my school, Tecumseh Vista Academy, and ultimately just with an iPhone. So this is something that we have the technology to do, and ultimately I think the part that takes the most time is the thinking of the task. What is it going to look like? What do I need to make it happen? Do I have a custodian there like Mike in this video to help me ensure that it doesn't fall over? And you can see this final 56 packs in order to reach the ceiling. Now, something that is really interesting is at this point, when you see that it actually came out to 56 reams of paper, yet you guys only said it should only take 55 and I think it was 0.15. So now what I'd like you to do, and maybe what we'll do is we'll go to a new page for this one. Go ahead and take a moment to share out, why do you think 56 was the real world answer, the actual solution, when math told us otherwise? Math told us it was 55.15. So take a couple minutes and try that out. Awesome stuff. So compression is definitely one of the most popular that come out when I do this with students, as well as when I do this with teachers. Seems very logical that, you've got a lot of paper there, a lot of weight, and it could be, I like the word over here in red, it could be squishing the other paper. We have gravity, so it brings up some interesting discussions about that. Did the paper get stacked in the same spot the height of the ceiling was measured? That's a great question to follow up. And I've had students ask something similar to that as well. Miscounting was another one that I noticed there. So definitely possible. I didn't miscount this time. Height is not consistent in most rooms. I like that one's being put on the screen right now. very interesting. If I'm in an older building as well, we have this talk with depending on the school I'm in. Sometimes I do co-teaching with other teachers in older buildings. Sometimes it's very noticeable that the floor is not necessarily level. So sometimes people will bring that up as well. And I see the stack was very slightly tilted. Awesome stuff. So great, all kinds of great suggestions here. And I really want to bring your attention to where this type of thinking comes out when we do traditional math questions. And when I say traditional, you know, thinking back to the textbook, I used a textbook for quite some time and I learned from a textbook. Usually this would be like part D, maybe part E, where it says what extraneous variables could impact the outcome. Something along those lines. And ultimately what you've given me here are all kinds of extraneous variables that I don't think my students, and I don't even know if you guys would bring up many of these if you didn't have the opportunity to watch it happen. When you see the paper being stacked and you're watching it and you see it in front of you, it's so much more real than just reading it out of a textbook. What I would always get from my students is I would get usually a blank spot there, a really, really poor, really poor response that really didn't show any thinking involved. So ultimately, they're just skipping that type of question, all that important thinking about what math, what kind of thinking we have to do, or what kind of insight we have to have in order to determine whether the math we're doing is actually going to help us in the real world. So, you know, students need to be aware of that just because the number comes out as 55.15, that doesn't mean that that's all the work that we need to do. We have to factor in all kinds of other elements. If we're talking about outside, maybe it's elements of weather or just the environment, the surrounding environment. So lots of great sharing there, and I really appreciate that. Shannon Smith here is asking, what grade do you do a problem like this with? I would say this problem would be definitely fair for students probably down into grade 6, possibly earlier. I've never been into the grade 5 classroom, but I'm pretty sure that you're dealing with, you're being at least introduced to ratios. I think even, I believe ratios. So in grade 6 for sure. I've noticed a lot of teachers using it in 7 and 8. In my class, I've used this in grade 9 academic as well as in grade 9 applied. Not necessarily because of this particular question where I'm trying to activate their understanding of proportional reasoning, but because of where we're going to extend it in just a few moments. So you've seen your Act 3. I'm going to pop over. It says my grade 5, Corey says my grade 5 would be able to handle it in terms of multiplication, not division. So awesome. So getting that idea of multiplicative thinking. And for those of you in the room who maybe aren't super comfortable with the idea of proportional reasoning, I know I knew how to solve a proportion as a math teacher, but for a very long time I wasn't clear on what proportional reasoning is. And ultimately it is just that, is going from additive thinking to more of a proportional or a multiplicative thinking. So here, having stacks of 5, you know, if a student could make the connection that 5 stacks is 24.75, that means 10 stacks would be double, right? Or if 15 stacks would be triple, rather than it being always adding on, adding on, adding on. So we're really trying to get to that multiplicative way of thinking. And Christine is agreeing that her grade 5s would be great, awesome. And Mary Jo, does the paper get compressed and will the answer be a bit off because of it? So I think that might have been maybe before we started chatting out here. Real life is so annoying with its inconsistencies. So yes, you're absolutely right. It definitely is. Math is usually, you know, kind of cut and dry. And I think it's really important for students to see that it's not about being right all the time. It's about the thinking that goes into it. Very nice. Nice, and Mary Jo as well wishes students wouldn't think of division as different from multiplication. Very, very cool. I like that. All right, so what I want to do is I want to take you ahead here to what this looked like in a textbook. So the way you and I would have seen this problem. Now, I think I may have prematurely introduced the idea of the 4-part math lesson, because all I did there, I gave you a task, and the reason I gave you that task was to give you insight as to where the minds-on is going to come from for our lesson tonight. Okay, so I'll say that again just to be clear. That task was to give you more or less a glimpse into what we would have done the previous day as we come into this 4-part math lesson, okay? Because I really want you to see the connection you can make between a minds-on and the previous lesson. So I would suggest that would be probably the action of the previous day. I do that with my grade 9 applieds, but I didn't want to go through a whole 4-part with that particular task. So we'll be taking a look at this in a moment. But I do want to break it down and look at what this would be in a textbook. And we have seen this problem before, and it would look something like this. You'll notice not as interesting as the way we did it. I think we could all agree, and I'm going to just put up I'm just going to put up right now, if you guys can go to your little check box right under your name in the top left of your participants box, give me a yes or a no. Looking at it visually with video, the way we did the stacking paper problem, would you agree? So yes, for it being video would be better than looking at the question with just words here. So let's see what we have for a response. So it looks fairly one-sided currently. Maybe I'll throw in an X just to go against my own thinking. No, no, great stuff. So I don't see anyone saying, yeah, you know what, I'd much rather have the word problem. Now, from a teacher perspective, sure, we can't take every problem and we can't make it visual, and I think it's bad if we do take that approach, because we also have to understand that much of how we test our students is with this approach here with words. So we still need students to be able to answer these types of problems, but I think when we introduce concepts, we want it to be as contextual as possible, and then scaffold them to a place where they can do something like this. So definitely not as interesting as before. So definitely not as fun. You'll also notice I could toss in clip art, right? It doesn't make it better. I could put my name in it or a student's name in it. I can maybe put in, maybe add in that it was at Tecumseh Vista Academy in the photocopy room. That stuff doesn't really matter. The students don't connect to it. And you'll also notice the answer key at the bottom. You got to see it happen, whereas, typically myself when I was in school and my students for 8 years would just flip to the back of the book and, probably not be super excited when they saw that their answer was correct. And a little bit of discussion going on to the side, which I think is great. So excellent, awesome stuff. I'm really happy that everyone's having a chat as well. So we can all be involved here. On a test, could we ask students to draw the problem first? I would say, sorry, is it Tessa? Tessa, yes, I would agree with you wholeheartedly. I think it's really important for students to be able to make that visual. Again, on a test or on an assessment of any type, we're hoping that students have seen this context so that hopefully it's a little easier for them to make the visual representation in their head and then represent that on paper, which is great. And I would agree with Mary Jo as well that students struggle with visualizing problems. And yes, that's great, acting them out. Yeah, that's ultimately what we're talking about here, is how do we help students visualize by showing them what math looks like. And then ultimately there is a lot of issues around or questions around literacy. Is the issues in math, is it more of a literacy issue or is it more of a numeracy issue? But I do think they are linked. I think there's a little bit of both involved there as well. So very good chat. And I'll try to come back to the chat box as well. I'll pause it where I'm at there so I can make reference to it as well. So what I want to do for a second is take a look at this original problem, and I want to talk about how we actually broke this thing down. And you may or may not be aware of it, but when we look at Dan Meyer's 3-act math task format, his format, ultimately with Act 1, it just gets you interested in what might be happening. It gets you questioning, like what are we doing here? Where are we going with this problem? So if you recall that Act 1 video, we just saw some paper and we just saw a wall in a room. I kind of made it obvious with the camera. We kind of looked up the wall, like scaled the wall with the camera, but ultimately nothing else was given. So it left you kind of wondering. And then we put the ball in your court. You guys came up with the questions, and many of you had actually brought up the same question that we actually solved, which was how many reams of paper would we need to reach the ceiling? Okay, so that was something we developed after you saw the question. So you'll notice not a whole lot of words necessary. A suggestion from Dan Meyer is, even if you're not using video, maybe releasing almost like a gradual release of the question, rather than giving a paragraph with the question at the end or the hook at the end. Why not give them a bit of the problem and then slowly release it? They call that developing the question. So take that time to develop the question, help them make that visual, help them feel like they're a part of that question. And then finally, typically I have my students ask what information they want or need to solve the problem. But in this case, we jumped right to it. We gave you the information, and then you guys actually got to see the solution in Act 3. So really effective, in my experience anyway, really effective getting students to engage in the problem, even students that maybe aren't in the so-called good at math group, but it really hooks them into putting their all in it and staying engaged with the task. So what I want to do is take a couple seconds here, a few minutes I should say, to deconstruct this task a little bit. And we'll go back to this idea that many of us got down to a unit rate. Okay, a lot of us did this whether you realized you were doing it or not. When you divided that 24.75 by 5, you were getting yourself down to a unit rate of 4.95 centimeters per one package of paper. Okay, so a lot of us did it that way. Some of us did it the opposite way. Okay, so those who went down to a unit rate then multiplied by, divided that number by the 273, vice versa. They took 273 and divided by 495, while other people may have divided 273 by 24.75 first and went from there. So essentially swapping a little bit of your order of operations, which is definitely allowable. Now, if we look at this, most of us use division of some sort. And what I want you to take a couple minutes is thinking about how we could do this, how we could take this task, and how we could take our solution that seemed really, really simple to us and look at how we could break it down for those students who may struggle with this task. So even though we had a few folks in the room who said that their students would be able to do it in grade 5, I'm sure there's also some students in your room that may have had struggles, maybe with deciding what they needed to do. Some students may have maybe put 495 on top and divided by 273, so not really having that understanding as to why they're doing what they're doing. Okay, so what I want to do is take this and I want to talk for a little bit about relationships. So what I'm going to have you guys do is use your little checkbox yes or no to respond to a quick poll here, just a quick verbal poll. You know what, maybe what I should have done was given you a multiple choice, but would you agree or disagree that data management typically is a strand that your students perform well in comparison to the other strands? So even if it's a struggling student, would you say that your struggling student performs better in data management than most other strands? Or would you disagree with that statement? If I had multiple choice, I would have put all 5 strands up there, but I don't believe we have that option. So I see quite a few coming in. So 8 would agree. If you're in high school, you know, if you're a grade 9 or 10 teacher, you may not have data management as a strand. Awesome. So quite a few people are suggesting data management seems to be a strand that students typically perform pretty well on. And what I'm trying to, I guess, throw at you here is the idea of how we can leverage that strand to break down most every other strand, including proportional reasoning. So what I want to do right now is I want you to take a second, and on the screen, if we were to look at this scenario, okay, if we're talking about how many reams of paper to get to the top of the room or to the ceiling, what would be the 2 variables that we would be relating? What is the relationship we are referring to here? Okay, so when we talk about X and we talk about Y, and this is something that even as teachers, even with math backgrounds, a lot of times we struggle with identifying what are the 2 variables that we can relate. So take a moment and use your text box on the screen. What are the 2 variables that we are relating for this particular relationship? Awesome, and I'm going to just give a little bit of scaffolding here for a few out there, is keeping in mind when we talk about the 2 variables, remembering that variables are numbers that can change. So we can't use numbers. We can't use a number like 5 or a number like 10 when we're describing a relationship, because those numbers can change. All right, obviously there's only going to be one number to get us the answer we're looking for. But when we talk about the relationship between those 2 variables, what are those 2 variables? The numbers would change, and then once we're at the top of the room, we would have our answer. Awesome stuff. Awesome. So we've got lots of people here. This is great. And even for younger students, you know, keeping in mind that they are very strong in data management, one area that typically students aren't very strong in is identifying variables, specifically the independent and dependent variable. So in this case, we are actually talking about, just like you guys have mentioned, the number of reams and the height of the stack. The number of reams is the independent, and the height of the stack is the dependent. The height depends on how many reams of paper I have. So that's very important, because what we can do, not only by trying to make or trying to bring up the idea of relationships whenever possible, proportional reasoning is a relationship in itself. So here we have a relationship, and a lot of times we ignore that relationship because we can find the answer quickly. So I'm suggesting that we really leverage that. So in this case, we're identifying our packs of paper, sorry about the blurred writing there, and our height. Everyone's defined it in a slightly different way, number of reams and, you know, height of room or whatever it might be. But ultimately, those are the 2 variables we're talking about. And even for a student who might struggle with that proportional reasoning problem, if it was a grade 5 student, or maybe it's even a grade 8 or 9 student who's struggling with, you know, which numbers do I divide? Really, when a student is having a difficult time understanding which numbers to divide, what that tells me is that they need to back up a step, because they're depending on memory. You know, they don't understand why they're doing it. They just want someone to tell them the trick. And if it's a trick, eventually they will forget. So I will always recommend to a student who's having a hard time deciding which ones divide and which number goes on top, which one's on the bottom, is to get themselves started with a table. And I think we could all agree that if I have 0 reams of paper, my height is going to be 0. And that's something that I really like highlighting, especially with teachers, because for so long I didn't realize how important or how useful this piece of information could be. But when I'm dealing with a rate or a ratio, I will always begin at 0 or at the origin, okay? And this is really important as students get into linear relationships in high school. They are very, very closely related, and we'll see why in just a few minutes. So starting at 0, 0, I can then begin adding on. Now, a student may say, okay, my next point I want to put in, my next XY coordinates I want to put in this table is 5 and 24.75. Other students might go right down to 1. They say, you know what, I want that 4.95 in my table. And then maybe they go up by ones, and maybe they start doubling from here, right? So maybe it would be, okay, so 4 and then 18 or 19.8, and then double from there to go up to 8 and so forth, to get closer and closer to the number they're looking for, to at least get a close approximate, right? And they can use their idea of what 1 pack of paper is to add up or subtract from that value. So we have a lot of really important, or really a lot of really effective strategies to get students started. And this table is super important because it really does help us as we move into high school, because the table will be something that they're going to use as they do linear relations and quadratics later on. So the table is one. But the other thing I want us to note here is that those 2 variables are the rate that we're talking about. We are talking about the height and packs of paper. This is a rate because we're dealing with 2 different units. And when we look at this as a rate, we can also look at this as a proportion. So ultimately what we have, if we look at that relationship between the rate, and I'm just going to grab myself a pointer here. If I look at my 1 pack of paper, so this is my height, and this is my number of packs. And over here I have height and number of packs. I can set this proportion up and then start looking at something very simple to extend this concept to, but now we're looking at solving a proportion. So this may not come up early in junior and intermediate, but it is somewhere that we can help students scaffold to. And what we'll start to see here is that when we look at the relationship between 4.95 and 273, ultimately what we're dealing with here is a multiple, right? This height is a certain number of times bigger than this height. And this number of packs, X, is a certain number of times bigger than this 1 pack. And when we organize it in such a way, what we end up with is the opportunity for students to be introduced to the concept of opposite operations. If 4.95 times some number is equal to 273, then it makes sense that that 273 divided by the original number will give us this multiple right here, okay? So rather than trying to teach students tricks like cross-multiplying or, I used to do something called Y thingy thingy. A colleague of mine at my old school used to, help students see that if you multiply the 2 numbers across from each other and then divide by the other, it forms kind of like a Y, and you'll always get the answer. It really doesn't matter how it's all set up as long as the proportion's set up. But the problem is that students don't have an understanding as to why they're doing it. Whereas here, they're getting this concept of multiplicative thinking. So in this case, we get our 55.15 as our multiple. And whatever we do on the top, we're going to have to do that same thing on the bottom. And we get our 55.15 packs of paper. So I'm going to take a second here. I'm going to just mute my mic really fast. If there's any questions coming up, I see them coming up in the chat pod. So I just want to take a quick peek there. Does anyone in particular, if you want to raise your hand, if you have a question, you can turn your mic on and we can chat about that before we move on. And just looking back to the chat pod, I think Andrika had mentioned we could visualize using real reams in the classroom. That's definitely something I've seen a few people share out videos on Twitter. You'll notice in the bottom corner, Mathlete Pierce, I'm on Twitter. Some folks have shared videos out. The one thing I would caution you always when doing activities in the classroom is really trying to weigh out the benefit, the time benefit, the time value benefit that you receive. So for example, here with this video, it's a 20-second video, but it took me much longer to actually stack the paper. So how much class time am I using to actually stack the paper all the way to the ceiling, right? Or maybe I have the 5 stacks and then we solve the problem, and then that night I stack up the paper and the students come in the morning and they can see it up on the wall. But really just be careful that you know, you're not sacrificing time that could be spent you know, deepening their understanding with, you know, stacking paper. So I've done that a number of times myself, and sometimes we wonder whether that's going to help or hurt in the long run. All right, perfect. Excellent. Yeah, and I noticed as well, I saw some talk about learning styles. I didn't see learning preferences, but I see learning styles, and you know, just my take on from what I've read and research on visualizing and so forth is that being visual is something that everyone who has the ability to see has, right? If you look around your room right now and you think of all of the items in the room that you may or may not have noticed was there, your brain sees those items and it knows what to pay attention to and what not to pay attention to. In math, we don't visualize nearly enough. And I think some students believe they're not visual simply because they've never been exposed to it, especially when it comes to mathematics. It's oftentimes when you visualize math, it's actually much more difficult than just doing an algorithm. An algorithm is something I can memorize. I can know it like the back of my hand and not really have to think about it. But when you visualize, you're forcing yourself to really think about what that means. So I would argue that that most of us would benefit from the visuals in the long run. Okay, a lot of people are turned off at first, especially if they haven't learned with visuals for a number of years, especially when they come into grade 9 and I'm trying to get them to visualize and they've never seen math. That can be very daunting for some students because they've been doing just fine with the memorizing. So they kind of learn the system, they figured out the game, and they want me to just continue along because it's much more work for them to actually understand what the math looks like. So just a couple pieces there as well. All right, awesome. So great discussion going on there. If I missed any specifics, that just trying to scan here. I do want to head forward here because we don't have a lot of time left. So I'm not going to stall too much. But with this problem here, again, really trying to lead you to see that a simple problem, or what could be simple, we could go really in depth with it in order to get some gains later. And this is where I want to show you what the 4-part might look like. So assuming this was a task we did the previous day, the next day I would come in with a minds on, and I might have something related to the topic. It might be related to the same scenario, but it doesn't necessarily have to be. In this case, what I gave them was a question asking how many thick packs of paper it would take to reach the ceiling. Now, since I've done this, I've also had some teachers say, well, you know what, why not, why does it have to be the ceiling? Maybe it's the height of the school, or maybe it's the height of the CN Tower, right? So you can really play with it but ultimately trying to get students to think along the same lines as where we were the previous day, activate that prior knowledge, and then move us forward. So the question might look like this. We're not actually going to solve it, right? But we could set it up with a table or a proportion, or we could just go straight to dividing as most of us did with that original problem. So that would be a decent minds-on to get us moving forward. And at this point, I would lead into the inquiry task for the day. And this one really takes the concept from the previous day and it builds directly on it. And that's what I really like about this particular series of problems. So no video. You already saw a video yesterday. Here is the task you have to work on. So I'm going to have you guys try to figure this thing out. As soon as you know the answer, I'd like you to put it up on the screen with a quick sentence explaining what it was that you did. Again, not revealing what this learning goal is. You may be pleasantly surprised when you see what you've done intuitively without mathematics. So I'll give you guys a few moments to work on this problem here. And just to mention as well, you can feel free to use the text tool on the screen once you've found your answer. And if you highlight your text with a Control A or Command A if you're on a Mac, and then look at the toolbar, there'll be a horizontal toolbar. You can actually change the color of your text. I kind of experimented with as well. And it looks like we might have a new page here. So I'm just going to put down the data up on the screen for you. Oh, slick move. Awesome move, Louise. I see the picture icon now. I'll definitely use that in the future. As we're sharing out here, I noticed a great question from Mary Jo about students that are having difficulty kind of moving from or transitioning from addition and subtraction to multiplication and division. I would say trying to push students to get them to a place where they could solve, for example, the 3-act math task, stacking the 5 papers up to the ceiling, or the 5 stacks up to the ceiling. I think we try to get them to do that, but they can't see the connection there. So I think getting them to a middle ground between the two would be probably best, and I would assume using a number line or using a table would be the best way to go about it, because you can encourage them to use even just simple doubling, as I had mentioned. So I would suggest, rather than going straight to multiplication and division, because multiplication and division is very abstract if you don't have some sort of visual or some sort of way to scaffold themselves to the answer. I would say the table would probably be a great middle point or midpoint that could really help them along. Awesome job. We see lots of work here. 106 is coming up quite a bit. Most people, it's funny because a lot of people will, take the 130.75 and then they'll take the 4.95, they'll multiply it by 5, then subtract, which is what I would do when I was solving this problem or working on this problem. That's the way I saw the problem. And what I realized after is only a few people would actually take the knowledge they knew from the previous day, which is the 24.75, and just subtract straight up. which is interesting. So a few of my students have done that as well. So really, pretty simple problem. Let's get people on a quick vote, yes or no, with the respond poll up at the top. Yes, this is an easy problem. No, it is not an easy problem. What do you think? Awesome stuff. Lots of people are saying pretty easy, pretty intuitive. Now, the surprising part is that this particular task is one of the learning goals that students struggle with at first, or did for my first 8 years of teaching in grade 9 academic. This isn't applied math, this is grade 9 academic math. Students would really struggle with this concept. I never gave it to them in this form. I would go straight into teaching them by giving them some examples and then, having them try some on their own. This way, students really, they get the answer very quickly. And I just want to share out, thank you so much for sharing out all the different possible solutions. Most of us did something similar to one another again, which is great. This is how a student in my grade 9 applied class did it. Now I should preface that they did know how to create an equation, and I know some of your students in 7 and 8 know how to make equations based on your patterning units. So this student, we introduced earlier in the year the concept of what a linear equation looked like, so they could pull it from a description. And in this case, this student took and recognized that there are 5 stacks of paper, and the height was 130.75, which ultimately is a point. That was something that really got me as very interesting in this particular solution. And then he simply subtracted. So when we talked about that additive and the additive thinking versus multiplicative, this student's in an applied level class, which means he likely struggled in grade 7 and 8 in math, and he used subtraction rather than division, and multiple subtraction rather than repeated subtraction using some sort of quicker method like multiplying by 5 first to get back. However, he's showing a clear understanding. This student's a level 4 student from my academic class who did this task. She recognized that there was a point again. She did this part down in the corner first, and I asked her this afterwards, which part she did first. This part in the corner was what she did, which is ultimately what all of you did. And then she showed with a table, then she showed what it looked like on a graph, which I thought was really interesting. So what I want to do is take a moment to show you what this looks like in the connections piece of this 4-part math lesson. So in the connections piece, what I want to do is show the students what I want them to see. And ultimately, those students saw it, but we just needed to make some final connections. What they saw was that with this particular problem, that they had 5 packs of paper and 130.75 centimeters, which ultimately is a point. And this particular learning goal is called finding the equation of a line given slope, which is my unit rate, and a point. And this is a topic that students typically would struggle with in my class anyway, when I first introduced it, because I did it in a very abstract way. So this is what I want them to see. And I'm just going to take you on a quick web tour here. I want my students to see this relationship. So this is what we did together to solidify the inquiry piece from that lesson. And while it's going very fast due to time, I have it in fast forward. Ultimately, this particular task, oops, let me just back up to right there. Ultimately, what this is outlining is exactly what you did. If we come down here and we look at that 4.95, subbing it in for m, that is our slope or our unit rate. And then we knew we had 5 of those reams. So 4.95 times 5 gave us 24.75. And I needed to solve the equation for b, which is what we call the initial value or the initial height, which is the height of the table in this instance. So subtracting 24.75 on both sides, we get 106. Now, That right there makes a whole lot more sense to you, I'm sure. And I'm just going to slide out of this to the whiteboard for a second. I'm going to clear our vote. Did people follow me? I know I'm moving fast because we're running out of time here, but yes or no, did that make sense how we kind of solidified that? I gave you the equation. However, my students had already seen a linear equation, so they had familiarity with what slope and y-intercept were. But ultimately, they're taking that point and that slope, they're subbing it in and solving the equation, and that is it. But this is what I used to do for my students. This right here is the first question I would give them to do this task. And I want you to look at the top. It says example 1. This is from my old note. I would give him this question, which is completely abstract. There is no context here at all. I would say, find the equation of a line given slope of 2 and a point 1, 5. We do the same steps. Students would struggle until they memorize the concept. So when we go back to those two groups, students who memorize and those who can't, some students would pick this up by the end of the period. Other students would struggle with it, or maybe get it, kind of stumble through it and then forget by the time the unit test came around, or by the time exam time came around, or whatever it might be. So ultimately now, this is the consolidation of my lesson. I can now refer to this abstract problem with a context. I can now ask the students and say, if there's a slope of 2 and we pretend that we're stacking paper, my students know that the thickness of this paper is 2 centimeters, and because of this because of this +3 in the equation, I know it's a 3 centimeter tall table it's on. Sounds kind of silly, but you can kind of picture that. And if I go up to the point 1, 5, that tells me that if I have one stack of paper on the table, on that 3 centimeter table, that means I have a 3 centimeter table with a 2 centimeter tall or thick stack, which gives me 5 centimeters total, which is where that 1, 5 comes from. And if my students have that clear understanding and they can visualize in their head what they did in the inquiry question before I gave them any math to do it, then I'm confident that they'll be, or at least have a better chance at taking that visual, that context, and that concrete representation. They can take that and then make it into something more abstract, which is what algebra provides us. This is the shortcut. So I used to give them the shortcut and they would just be completely lost. Now we work our way to get to the shortcut. The algebra is the shortcut. We don't want to rush it. We want to make sure that it's completely visual for them, so that it will be retained, that they won't lose the information before the end of the semester or before the next school year, and then they move on from there. So I'm really running out of time. That was the consolidation piece and the 4-part math lesson. I do have a quick link. I will show you what task I would do the following day, but we won't go through it simply due to a lack of time. But up in the chat box, I've just posted a link to a blog post on the 4-part math lesson, which also includes these stacking paper activities. So you're more than welcome to use them off of my website, Tap into Teen Minds. The following day, what I would do is I would then take this concept and I would change it up slightly to extend the concept. And I'd now ask them, how tall is this particular table? And I would give them 2 heights. Now, again, we don't have time for it this evening, but just to give you some context as to where this question would go, this is giving students 2 points, and they would have to find the equation of the line. So students would ultimately solve it using their own inquiry and intuition, and then we would formalize what they're actually doing, which would be the introduction of the slope y2 minus y1 over x2 minus x1 formula. So at this point, I don't have time to go through all the solutions with you, but I do want to open up the floor here to I had an idea. I wanted you guys to do some thinking and create a task, but I don't think we'll get there today. So I'm going to open the floor up to any questions, and feel free to use your mic if you want to share, or we can just go straight from the chat pod. And just going back into the chat pod, I see Mary Jo, students who memorize are often not able to use the concepts in a new situation. So, echoing what I had mentioned at the beginning, that, regardless of whether you're in the good or the, not so good at math groups, both groups struggle when they aren't familiar with the situation. So that's what I'm trying to tackle here. And, I'm hoping that some of you will come on this journey with me and definitely stay in touch with me over Twitter and email. So we can, build on these ideas together and see where they take us. And Mary Jo again is asking whether it would always be on a single day, or could it be over the course of several days? I would say that it definitely could go over the course of several days. Even like tonight, right? In my mind, I had more planned for us to do, but there was some good discussion earlier. You guys were sharing out quite a bit. So, this will happen. That's one of the negatives of using inquiry and, getting kids to be a part of the lesson instead of just sitting passively in class, is that you're going to run out of time sometimes. And that's okay. You have to be okay with it, as long as you're looking at that long range of what are we actually hitting. If I'm providing students with value, like we did today with teaching them how to use a table and a proportion to solve a question that traditionally we would just use division for, they're probably gaining more from that than from me trying to rush through in order to get to that next siloed topic the next day. And just to kind of reiterate for Tessa, the first task we did would have been the previous day. So stacking the 5 stacks on the floor all the way to the ceiling, that would have been one day. Then what we had just done with slope and a point, the 1 stack on a table, that would have been the next day. And then finally, the 2 stacks on the shoulder table would have been the following day. So the 3 tasks we looked at today were essentially like a 3-day sort of experience. However, each day I would have broken it up into a 4-part math lesson. So have a minds on each day. The tasks serve as the inquiry phase for each of the 3 lessons. The connections would be trying to address those learning goals. So if it was doing it in a table in a proportion on day 1, day 2 was algebraically solving for the initial value to create a linear equation. And then on day 3, we would be doing the same thing by introducing the slope formula.
I know people might type.
Great question.
Oops, sorry, Kyle, didn't mean to interrupt you. Go ahead. I'm just going to move to our thank you and feedback link slide so people can grab that if they've got to go now that it's 9 o'clock, but go ahead.
Absolutely, yes, no problem. And yes, Kristen, typically the inquiry piece, I usually have students working in pairs, maybe in threes, really open to them. I want them talking, I want them trying to figure this thing out, and ultimately I'm trying to get them to, as I mentioned earlier, bump into the learning goal. So if I can get kids working together so that they might stumble upon the trick, right? Like, because ultimately math is a trick. Like, we need to know why the trick works, but when we do math, when we use variables, why are we using X? Well, we're using X so I don't have to write the entire word, right? So, I mean, these are all shortcuts. So it's the language of math. I want them to bump into some of these things. For example, in the last task with the 2 stacks, a lot of students will intuitively find the slope of the or the thickness of the stack using the slope formula, but not in an algebraic form. So all we help them do is to kind of clean up the form by saying, listen, ultimately you're subtracting these 2 numbers always on top. Well, guess what? That's your dependent variable. and then you're subtracting your x variables on the bottom, and then you're dividing them. So let's just put them together. And guess what? We could represent that with a formula to make our lives a little bit easier, a little more organized. So I try to keep them collaborative, and then hopefully by the end of the lesson, when we get into the consolidation piece, students can then go into more of an independent sort of practice, you know, getting more exposure with less contextual problems. And for Aaron saying we got lost with the slope in the equation, that piece ultimately is more or less my fault, simply because we're running out of time. Usually, you know, we do a much better job scaffolding. I worked with primary teachers 2 days ago at a school in my district, and every single teacher there who had, you know, about half had, you know, self-proclaimed that they were a non-math type person. We had the talk about growth mindset, and they did all of these tasks. However, they had a little bit more time to do it. We had a whole morning to do it. So with time, I really feel confident that you would be completely with us on it, because it would be more of an inquiry piece, and then we would tag the name to it afterwards. But due to the time, I had to essentially rush through the last few slides. So I really hope that doesn't discourage you from engaging in this type of task.
Absolutely, and it's fantastic, Kyle, that you've provided us with all those resources, and I've put together the web page already for tonight's session, and I'll post a link again for that. But you guys will get a follow-up email tomorrow, actually possibly later on tonight, and that includes the link to the resource page, as well as the links on that resource page also lead you into Kyle's part 2 and part 3 of this series, and it looks like there's still spaces available in both of those, so you can certainly go in and register. We have a lot of other math sessions as well, so if you're looking kind of to just broaden your skills, your knowledge, and explore a little bit more, we've got lots out there in the calendar. And I know, unfortunately, one of the sessions I thought you guys might find helpful is also full, but we'll make sure that you've got the link to our past webinars and resources page where everything gets posted following a session. But we have one that's on rethinking assessment in mathematics, and you may enjoy some of the thoughts in there as well, and tying it into in some of the questions I saw up there in the chat. And as I said, there's lots of math in there throughout our calendar, and more being posted in the coming weeks, we hope. And we do thank everyone for their time tonight, and thank you so much, Kyle, for giving such a detailed and in-depth presentation and exploration and consideration of a 4-part lesson, a 4-act lesson. And I just see Amber's comment there. You definitely need to sign up, Amber. I've posted the links actually up in the chat, so if you scroll up through your chat, you'll find those links.